Here is example number 3, final answer. If you have this equation, then you probably don't need to watch the rest of this video. If you want to know how we got here, then watch the rest. I'm now showing a more complicated example, number 3, aluminum bromide. Aluminum, from your periodic table, is a positive 3 ion. Bromide is a minus 1 ion. So we've got a little work to do here in the beginning. Aluminum bromide is not one of each. You'll need 3 bromides. Okay, that's aluminum bromide. Potassium hydroxide. Potassium is K. That's confusing, but it is from the Latin kalium, K. Hydroxide. Hydroxide is polyatomic OH minus. That's all there is. 1 plus, 1 minus. Now, let's do the other side. Aluminum hydroxide. Aluminum is the same plus 3 ion it was in the beginning. Hydroxide, OH with a minus. Small polyatomic ion. OH with a minus. You should see that we need more of them. We'll need another OH minus. And yet another OH minus. So 3 hydroxides will bond with 1 aluminum ion. That one's done. How about potassium bromide? Potassium, we've seen before, is K with a plus. Bromide, we've seen before, is Br with a minus. Okay, these are now translated the words into pictures. Everything looks great. We're ready to write the first part of the equation, which is the formulas. Al, Br, 3 is what I see right there. Put a line in front, put parentheses behind. I see KOH, line in front, parentheses behind. This is the change from reactants to products. I see aluminum with 3 hydroxides, which is written here with parentheses. Line in front, parentheses behind. And lastly, I see KBr, line in front, parentheses behind. Now I'm ready to balance the equation. Let's take a look here. I see 1 aluminum in the beginning. I see an aluminum in the beginning, and I see an aluminum in the end. That's fine and dandy. I see 3 BRs in the beginning. I only see 1 BR in the end. So I'm going to change that and make it balanced by saying we need more bromines. Br minus. Squeeze in another Br minus here. Poorly done, but there you go. Those bromides must come with positive ions attached. You can't just have negatives without positives. So their partners will be the potassium ions, K plus, K plus. So that has balanced the bromides. There were 3 in the beginning, 1, 2, 3. There are now 3 in the end associated with potassium ions. Not really bonded, but associated. Okay. Go back over here now. Are the potassium hydroxides in balance? The answer is no, but we can easily do it. There's 1 potassium here. There's 1, 2, 3 in the end. So let's add a couple more potassiums, K plus and K plus. Once again, for every plus there's a minus, so let's put in their partners, OH minus and OH minus. So now that is balancing the potassiums, 1, 2, 3. You should see 1, 2, 3 hydroxides, which happens to conveniently balance the hydroxides here. Everything is good. I'll ask you to pause now and write the coefficients and the phase notations. Here is what I see. I see just 1 aluminum bromide. You can write a 1 here or you can leave it blank. So in this case, I'll write the 1. I see 3 copies of KOH. 1 copy, 2 copies, 3 copies. That's a coefficient of 3. I see just 1 aluminum hydroxide. I'll write the 1. You don't need to. And I see 1, 2, 3 copies of potassium bromide. That's a coefficient of 3. Phase notations. Is this soluble? Yes. Is this soluble? Yes. Is this soluble? No. That's your precipitate there. PPT, precipitate. And this is AQ, aqueous, because it's soluble.